Hello everyone, this is Chris back again with the Ancient Scholar. Today I'm going to talk about something a little different than I normally talk about, and I think this is going to lead into a rather large series of videos that I'm going to do on mathematics. And I'm going to try, if I might, I'm going to try to get this up to the level of maybe basic calculus. And I know that there are probably a lot of people out there thinking, oh my god, I can't do calculus, I can't do all this advanced stuff. And I hope the goal is to try to present a case for math that is intuitive and perhaps perhaps easy or easier, perhaps easier to understand and easier to work with. And so that's kind of my goal. But before we get into that, I think what happens is sometimes we fail to really grasp some of the real basic concepts of mathematics, and that's where some of the difficulties arise later on in mathematics is that we just perhaps didn't really get a good grasp of some of the basic concepts, and in fact it was the basic stuff that maybe we were struggling on when we went on to more advanced concepts. So we'll just take a little time to discuss just some of the basic things. Now, I'll preface the rest of these discussions by saying that I've never taken calculus. I've never taken it in high school, and I've never taken it in college. I've actually had to teach myself. So I am not... My formalisms may be very different than what they teach in a conventional class, simply because I, like many people, attempt to understand things my own way. Obviously, we all have different styles and ways of learning and understanding. So some of the formalism, I'm not huge on mathematical formalism to begin with. I'm kind of a ghetto mathematician, if you will, in that I like what works, what gets a job done. It doesn't have to be pretty. It doesn't have to necessarily be formal. As long as I understand what's going on and I can work with it, I'm not as interested in a lot of the formalism, so I'm going to basically gut a lot of formalism, a lot of history out, and just try to get to the point. Okay, before we get there, I just want to talk about some real basic concepts, and I think where we'll start, because I'm assuming most people have had some basic math, and if they had to take some basic math classes in college to get respiratory, nursing degree, what have you, there's a basic math component. And hopefully everybody's good at this point, because there's basic algebra that you use for dosage calculations and so on. So I'm assuming people know that. People know a little bit about fractions and decimals, and I actually have some other videos up on some of these concepts if you need to refresh yourself, and maybe I'll make some more. But what I have here is I have the number line, and what I have two lines, really. I have a horizontal line here, and a vertical line here. And what we generally do is we call these axes, or an axis, when we're talking singular. And when I'm talking about something horizontal, generally what we do is we call that an x-axis. Okay, x-axis horizontal. Now if something runs vertically up and down, like a column instead of a row, we will call this the y-axis. And what we can do, and again, I'm not trying to insult anybody's intelligence, I just want to start off basic and make sure we're all on the same page. What we can do is we can graph relationships using a horizontal and a vertical axis. And what we do is, where the two lines intercept here, we'll call that 0, that point. Obviously, point is infinitely small, but we'll make it large so we can see. At that point, x is 0 and y is 0. So everything's 0, and I go above on my y-axis, and these are positive numbers. So positive 1, positive 2, positive 3, 4, 5, 6, and 7. Now if I go below the horizontal axis on my y-axis here, those are negative numbers. Negative 1, 2, 3, 4, 5, and so on. Likewise, if I go to the right, on my x-axis, that'll be positive 1, 2, 3, 4, 5, 6, 7, and so on and so forth, ad infinitum. If I go to the left on my x-axis, it'll be negative 1, 2, 3, 4, 5, 6, 7, 8, ad infinitum. So hopefully that's the basic topography, if you will, of what we're looking at, with everything starting at 0. Now let's say, and I love to make math a little bit easier to appreciate when I think a lot of times we just keep math abstract and we don't really relate it to the physical world, and we use math to explain the physical world. So why do people teach math and they don't give you something to really think about other than just imagine that x is just something? What's that mean? So let's just give ourselves a basic scenario. Let's say that every day I have to pay $1 more in taxes. That should pique everyone's interest, right? Talking about politics, we won't get too political here. So every day I have to pay $1 more in taxes, and the best day of my life is 0 here. Maybe I'm just born. And I don't have to pay any taxes on 0 days. I'm good to go. And let's just say that I'm going to make my x-axis days. Okay? So these numbers will now be days. And my y-axis, I will make dollars. Alright, so at 0 I don't have to pay anything, but every day thereafter I have to pay $1. $1 more. So let's kind of figure out what that means. So day 0, nothing. Okay, at day 1, I have to pay how many dollars? I have to pay $1. Okay? So I'm just going to put a point right here at day 1 and right here at dollars. And you can even put a little dollar sign here if you want. And then at day 2, I have to pay $1 more than I did the day before. Maybe that's a better way of putting it. $1 more than I did the day before. So if day 1 I paid $1, day 0, $0, day 1, $1, day 2, I have to pay how many dollars? Well, 1 more than 1 is 2. Then day 3, I have to pay yet another $1, $3. Day 4, yet another $1. And day 5, another $1. Day 6, another $1. Day 7, another $1 yet. Now what I can do is, now that I put those points for days and dollars, I can graph and I can make a line here. Because I now have a relationship between days and dollars, and I can turn this this mathematical relationship into something that's a little more tangible, and what I get is I get a line. I get a line. Now we can do a lot with this information, and I'll show you in subsequent videos, but I want you to think about it. There is a relationship between x and y, between dollars and days, and we've been able to graph that relationship. Is there maybe something more we can do? Maybe a formula, a general formula that tells us lots of information about this data. And there is, and we'll talk about it in subsequent videos. Okay guys, thanks for hanging in there. Take care.